All right, thanks everyone for coming today. Today I'm just really excited to tell you a little bit about what we've started calling the software singularity, and how we are starting to use AI agents, what we're starting to learn from how we use them, and how we're actually building a platform to make AI agents easier to use, better to use, and of course using the agents to actually build the agents of the future. What's really exciting about working in AI right now is we are really entering a new industrial revolution. And I think what's surprising about it is that it is happening faster than we think. So one analogy that we like to use is that in 1902, there were 130,000 working horses in Manhattan. And one of the major problems of the day is that horses, they do a lot of great things, but one of the things that they do is that they produce a lot of poop. So there were all these conferences about what can we do about all this poop that the horses do. And one of my favorites was, I think in 1898, there's a whole conference where they got all the brightest minds of the day together. They're like, okay, what do we do about all these, all the poop that the horses are producing? And their conclusion was, there's nothing we can do. We just have to live with this smelly behavior, and we have to live with it. 10 years later, the Ford Model T comes out, and just in 10 years from 1902 to 1912, the number of cars started to outnumber the number of horses in Manhattan. And what's exciting about software development and where we are in AI right now is that 1912 moment is right now. So right now, we are hitting this inflection point where, for a lot of key applications, AI is starting to replace the work that was coming before, starting to outnumber the amount of work that was being done before. So what I'm going to talk about in this talk is, so first, I'm going to talk a little bit about what I like to say is how I started to feel the AGI. So what were some moments, particularly over the past year, where I started to realize, hey, there's something new happening. There's actually an inflection point in performance. What I've learned about using AI agents to automate some of the key workflows and the key work that we do. And lastly, what we're building at together to enable this great agentic future. So I'll start with kind of my feel the AGI moment, and really it's going to be two things. So one is almost like a pet project, a long-standing research problem that I've been looking at for the past 7 years or so, starting from the very beginning of my PhD, and then also moving on to my day job, which is writing optimized GPU kernels. And I think hopefully by the end of this section, you'll see why we're so excited about AI and these agents and what they can do. So I'll start with this pet project. So we'll cast our mind back to around 2018. We were doing this project where we were trying to analyze about a decade of cable TV news. So we had collected a decade of footage from CNN, MSNBC, and Fox News. And we were trying to see, what can we do with it? Can we start to answer questions? And our thought at the time was, hey, there are these things called pre-trained machine learning models that can start to do something. There are things like face detectors and object detectors and things like this. And we're wondering, okay, can we start to use them to do anything useful? And at the time, so what we had to do is we had to build all these really complex systems. We basically created a whole query language, a whole database just for video. And at the end of that project, we could do some interesting things. We could find all the interviews with Jake Tapper and Bernie Sanders on CNN. We could cut out all the TV commercials. I built a little app to tell me when a parking spot opened up next to my dorm at Stanford so that I could go move my car. And we were doing things like orchestrating these really complex multi-hardware orchestrations. So we were taking these models, we were actually running them on CPU at the time because it was more cost-effective to run these ResNets and things on CPU. But at the end of this, after all this effort, you'd spend a bunch of manual effort, and then you would still kind of struggle to detect these video events that you really cared about. We kept working on it for a few years. So basically the story was, at the time, the models were struggling. They weren't quite good enough. And we did a lot of fundamental research pushing this. So we developed these complex algorithms around graphical modeling, using things like the triplet method, weak supervision, to try to aggregate these noisy signals. But it was still quite challenging. So around 2021, 2022, we were like, okay, maybe there's a different approach. These ChatGPT applications might start working. And what's really exciting, what really, I think, one of the things that really convinced me that there's something new happening here is that this summer, I came back to this problem, and I took a freshman intern who had very little coding experience, very little AI experience, as, hey, can you build a system using modern tools to do this thing that I had spent 3 or 4 years of my PhD trying to do? And what she did in one summer was she was actually able to build a whole agentic system up from scratch, completely on open source models to get state-of-the-art performance in video analysis, long-term video analysis. So these are things like take a 1-hour video. There are these complicated benchmarks where they're like, oh, the person who walks into the kitchen at minute 37 and then talks to this other person, what is their relationship to this other person later on in the TV show? And the answer will be like, oh, I'm secretly your father or something like that. And the surprising thing is that a relatively simple system with language models, some caption search, bringing the images into VLMs, building some interactive actor critics, so you can have one language model try to find the answer, another one interrogate it and say, hey, are you sure about that answer? What evidence do you have? Just with these pieces and really a simple together API key, we were able to achieve state-of-the-art performance on all these difficult video benchmarks. So that was one thing. That was one moment. It was like, hey, that thing that I worked years on before, now a freshman can outperform all those systems in one summer. But okay, that's a pet project. Maybe that's an exception. The other thing that really piqued my interest is that I started trying to use these AI agents in my day job. So my day job is GPU kernel development. For those of you who are not familiar, so I basically run the Together Kernels team. We're a group of about 15 to 20 PhDs, researchers who are really trying to bring frontier research to production. It's a very it's a pretty strong team. We have a couple professors on the team. What we do all day, if you're not familiar with a kernel, is basically, if you think about a machine learning model, it's basically a series of operations. And a GPU kernel is the code that actually takes those operations and runs them on GPUs. So these will be things like attention or gems or various point-wise operations. And it's really quite key to getting these models to run correctly, because if you don't have the ability to run these models efficiently on the GPU, first, you may not be able to run all the models you want, but you also want to get all the price performance, the inference speed, the efficiency to really make your applications work. And our day-to-day experience is that this set of skills is both extremely important and there's extreme scarcity. So every day we have to ask the question, what is the highest impact thing that we can do today for the business, for our customers, to make our customers happy? So it's a perfect thing that we could say, if we could make the whole team 10x more productive, we would see that instantly. The customers would be immediately able to see the benefit. So one thing we started to do this summer is we started to look at, hey, can they actually help us write our kernels? And there's been some interesting research work on this. So there's some great work out of Stanford, this benchmark called Kernel Bench, just trying to answer this question, can LLMs write GPU kernels? How good are they today? And if you look at this research and kind of the top line results, you might see a somewhat pessimistic answer. So these benchmarks, they look at, hey, can we take a language model? Can we just generate a kernel from scratch? They have something like less than a 30% success rate for generating these kernels. So you look at this, your first response might be, okay, maybe these language models aren't quite there yet. What we found is that this perspective is kind of like going back to 1912 and saying, hey, these car things are great, but they can't drive themselves back to the stable. My horse, I could just leave it around and eventually it would find its way home. I can leave it in a field and it'll feed itself. These cars, I have to fuel them, or I have to drive them. I have to figure out how to use this brake and the steering wheel. But really, that if you think about that misses a lot of the great things that we use cars for and the great capabilities. And one thing that we found this summer is that if we worked with the AI agents, if we worked with these tools, we were able to accomplish things that we weren't able to do before. We were able to do things faster and write kernels that were more efficient. This is just one interesting one. So this is a particular MXF4 matrix multiplication. If you're not familiar, this is basically a new data type that NVIDIA introduced in their latest generation of Blackwell GPUs. So basically, as soon as we got access to these, we were really interested, can we make this operation go fast? Can we really use these new FP4 data types? And if you look at this graph, it's a little bit tongue-in-cheek, but one of the interesting things is, so at the beginning you see you spend about a week trying to get the kernel to do anything at all. Then you start optimizing, it gets faster and faster. You can start going faster than some of the reference implementations out there. But then we kind of hit a little bit of a plateau. And at that point, we said, hey, can we actually use these AI agents to make things go faster? And what we found is that we could take these, these really expert engineers, augment them with AI, and then we could get new performance. And you can see it just go straight up and to the right, to the point where within basically a month of getting access to these new GPUs, we're able to write kernels that were faster than some of NVIDIA's fastest kernels. And of course, NVIDIA has had a whole 1-year head start. They have hundreds of engineers. This is basically one guy, one engineer, augmented with Claude Code, can achieve these new things and really write these fast kernels, use these new features, and make things really work. So once we sort of realize this, the next question is, how do we build it for this future? And so now what I'll talk about is a little bit what I learned about kind of this flip to AGI, these field to AGI moments, what I've learned about using these agents, and then at the end I'll talk a bit about specifically how we're building for this agentic future together. So what I learned about managing AI agents, I'll basically break it down into 3 lessons. But I'd say that the overarching theme is that if you're working with these AI agents, it's a lot like working with junior employees. So working with a new intern who doesn't have as much context as you, working with a junior employee who is talented, very, very smart, but doesn't have all the experience that you do. So like working with any new person on your team, the first thing that you might want to do is just divide up your work into bite-sized pieces. So you're not going to go up to the intern and say, hey, you've been here 2 minutes, now go fix all our profit margins across the whole company, rewrite our whole system, and do everything from scratch. That's not something reasonable that you'd expect a new person to do. Instead, what you do is you'd say, hey, this is a very specific first task that I'd like you to accomplish. These are the very specific things that I might expect you to do, let's say, in a week or a couple weeks. And here's maybe a basic step-by-step plan. So I'm going to try, using my experience of having done this a lot before, this is how I would go about it. First write down a design, then write down some tests, build something, and then iterate on that. So that's the first lesson. So divide your work into bite-sized pieces, help the AI agents move along. Then as they're working, you want to really help them get unstuck. So you want to explain the basic things about the code base. So here are things that you might want to know about. Here's where this data is. Here's where this key functionality is. Here's how all these pieces work together. And then as it's going, you can kind of watch it go along. So these AI agents, they'll kind of work for a bit. Sometimes they can get into these rabbit holes, these pitfalls. And just like you don't want a new member of your team to just rabbit hole doing something new, you want to work with the AI agents, really help them say, hey, I've noticed that you're about to do this thing. Maybe in the kernels that I write, you're about to go try to use this set of hardware primitives, hardware abstractions. But I know for this particular task, you want to do something else. So you really want to work with the AI agents and help them get unstuck and point them towards the right path. And then the last piece is that you really want to give the AI agents the tools to succeed. So I think if you look kind of in the broader discourse, there's been a couple of things like, oh, be very careful with your AI agents. I took this code, I ran it in production, and it deleted my whole database or something like that. And there's some value to that. I think the same guardrails that you'd put on a new intern, you're not going to give your intern production access to your whole system. You probably shouldn't give AI production access, but you don't want to handicap it as well. So one thing that we do is that we just give all the agents direct SSH access with Docker image to a dev environment where they can go iterate and work on their own. So you don't want to handhold it too much. The same way that if you have a new member in your team, you're not going to sit with them and say, every line of code you write, you have to stare at it and make sure that it's okay before you go on to the next one. You really want to give it tools. And then once you're there, you can start to build up a whole team of agents. So in the video case I was talking about earlier, you had one set of agents working as an actor, trying to figure out what the answer is. Another set of agents working as a critic model to say, hey, I'm going to just audit your logic here and look at what is right, maybe what is incorrect. And then 2 agents working together, even if they're the same model, even if they're the same set of models, they can catch those holes in the logic and build better. So if you kind of view your AI agents like a team this way, we found that it's really productive to orchestrate them and to help them work together. Lastly, I want to talk just in this section kind of what it means for building up organizations. So if I know we have a lot of C-suite folks in this audience, how do you kind of build an organization for this future? The first point I'll make is that there's been a lot of talk on Twitter and the broader discourse about, is there going to be an AI recession? Are we going to see are we going to see a lot of people replaced by AI? I think we're not quite there yet, and I'm personally not too worried about this particular future. And the reason is simple. So if you are working in a competitive environment where your output really matters, and you have a tool that can take one of your engineers and turn them into a 10x engineer, the next thing that you're going to do is you're not going to go fire 9 of your other engineers. You're going to take those tools and then build a 100x team that can do much more than they were able to do before. And likewise, when you're hiring for this new future, I think one of the things that's really become clear is that everyone is sort of in a manager role right now. So you're either managing people who are using AI agents, or you are kind of managing your own little team of AI agents yourself. And in this environment, the soft skills really matter a lot more than they used to. So that's because clear communication is really key. When you're trying to convey to the agents what you want to do, when you're trying to help them get unstuck, that's really key. So that's, I think for me, something that's been very important for how we're building for this. Okay, lastly, I'll just talk a little bit about what Together AI is building and how we're actually trying to build a platform for this agentic first future. So the really exciting thing about this is, and the reason that I like this 1912 car analogy so much, is that we really are just at the very beginnings of this new industrial revolution. So if you go back to 1912, what the cars look like, they look very different from how the cars look today. I think we can look forward to a next 100 years of innovation, really interesting things. Things like I watch a lot of Formula One myself, and the cars from the 1940s look very different from the cars today. So I think we're about to see a very interesting future. What we're building out together is really the full end-to-end model platform to enable this AI-first future. So we have an inference service where you can run your agents at the best price performance point, where we have fine-tuning so that you can take your agents and really adapt them, specialize them for your particular use cases. We have evaluation APIs, so you can figure out which use case, which agent is the best for your use case. And of course, we go all the way down to the full cloud level, so we have a lot of great customers who are training and fine-tuning the next generation of agents on our cloud platform. Across that whole platform, we are really obsessed with performance and getting industry-leading price performance. So that's both making sure that you have the fastest agents so that your agents can respond to you better. You can get more productive work done for each human hour that you're putting into engineering, but also the best price performance guarantee. So if you are really seeing this future where you're going to augment all your workflows with a lot of agentic work, you really want to start thinking about those price performance trade-offs. So together we can do things like make the inference 3x faster than some of the other hyperscalers in inference. We can make the inference 2.3 times cheaper with a mix of our systems engineering, speculative decoding, and really basic research background. What my team is doing, we're doing things, we're building kernels specifically for agents in this agentic future. So for example, one of the things that we're working on is this idea of a mega kernel. You take an entire model and you put the whole thing into a single GPU kernel. And what this ends up looking like is a lot more like old school distributed systems engineering, where you can get a lot more out of the GPU. You're not doing one thing at a time. You can do a lot more operations at one time and really get up to 2 times better performance than some of the best open source inference engines out there. Our research roots go deep, so we also work on basic research in terms of algorithms like speculative decoding, where you have a small model that can help, that is not as intelligent as a big model, that can run a lot faster and actually use that intelligence to speed up the larger model. We recently put out something called Together Atlas, which is really exciting because it's an agentic workflow that can actually learn from your usage. So the more you use the platform, the more you use a endpoint backed by Together Atlas, the faster it'll get. It'll actually learn from your traffic pattern and learn how to make the model go faster. So you can start to see these little seeds of the systems improving themselves. We also do a lot of fundamental research. So that video project that I talked about at the very beginning is along these lines. So can we take these classic, very challenging problems that are interesting to folks, and can we build the best agentic systems for them? So that's things like how to orchestrate agents, how to get them to work together, how to evaluate them. These are just two things recently. So on the left, we have a data set called Future Bench, led by our agents team, which is really trying to evaluate the agents by saying, hey, one way to test their knowledge, test their reasoning capability without worrying, did you see this in the training data, is to actually just write down questions where we don't know the answer yet. So can you predict what a particular stock price is going to do in the next week? Can you predict how something is going to go? This is we found to be a really interesting way to evaluate these agents going forward. Of course, also putting out basic research on how to automate and augment some of our very complex engineering workflows. So when someone comes to us with a new model that we haven't seen before, how can we look at it? How can we figure out what are the bottlenecks? How can we figure out the best way to host that and get the customers the price performance that they need? And really, I think if you take a step back, what we're trying to build here, and the reason that we go back to this phrase of software singularity, is that we are really starting to use the AI agent. So all that research, all the kernels that we write are all augmented, sped up, accelerated by AI agents. And now we're using that research, using those basics to go build a platform to then build better agents in the future. So we're really starting to see this very exciting feedback loop where the agents can make us more productive, and then we can go build a better platform to make the agents faster, more productive, work faster. And that's what we're building it together. I think we'll have some time for questions. And yeah, we're just really excited about this agentic first software singularity future. Yeah, thank you so much for listening today. I think we have a Q&A now, so we have a couple microphones going around.
Thank you very much. That was a great speech. And I got to say, the parking spot at a Stanford dorm is a hilarious, ingenious use case for computer vision. I don't think you got enough laughs out of that, but well done. I'm curious, it makes sense that you want to build a workflow that understands your traffic patterns and understands how to do your tasks more effectively and more efficiently.
Right.
How do you combat against, or how do you ensure innovation rather than just doubling down on the same thing over and over? And that's kind of the general AI question, but how do you protect against that?
Yeah, I think so. One of the great things I love about AI and the community and the AI research community, and I think something that I hope that we keep going forward, is a relentless curiosity about things. So people are always asking, how can we do better? How can we build the next model? And if you look in the history of AI, so certainly at the start of my PhD, I was doing things that over the last 10 years we've seen. I used to have to. When my mom would ask, hey, what do you do? I'd say something like, oh, I'm looking at these video things. And she'd be like, oh, yeah, okay, I get it. Now we're at a place where things are a lot more applied and a lot more impactful. But I think one of the really exciting things about the AI community is that we've really kept that curiosity. So we've done research into new architectures, new models, new ways of doing things. Like we're looking at other architectures like Mamba, successors to the Transformer. We're looking at things like diffusion language models. We're looking at what might future hardware platforms look like and how might they change and how can we start to co-design the AI architectures with them. So among all the things, I think as long as we keep that curiosity about what the best thing to do is, how to do better, I think we'll continue to innovate, and we have a long way to go and a lot of interesting stuff to do.
Great, thank you very much.
Thank you so much for your talk. So one thing I personally connect with is the fact that you said that there was a sophomore, you assigned a task for 1 month, and he had no coding skills, and then he was able to do that, with AI. So here my question is that, like, getting things done and actually learning something, there's a very huge difference. And as me, I've done tasks before where I don't know how to, I personally don't know how to code, but then I still have built softwares. Now here, how do you ensure that, like you bring, like as you're an experienced person, you know what's going on with agent. But someone who doesn't really know who's coming into this world, how do you ensure that they're learning and not just getting things done?
Right, right. That's a great question. So I actually think about this a lot, and I had in some older version of the slides, I had a slide about this, particularly for new engineers or young people coming into the field. And I think there's two points I'll make. So first, what we found is that the more experience you have, the deeper your background knowledge, the more domain expertise, the more you're able to get out of the AI agent. So at our company, there's this very interesting thing going on where the higher up the org chart you go, the better with AI agents you are. So our CTO is better at using AI agents than me. Our CEO might be actually better. I think he actually builds apps in his spare time with his family sometimes, which is pretty exciting. So that would be the first point I make. So if you're new to this field and you're learning, you want to use the agents to help you learn better, but you don't want to shortcut the learning process. You actually want to build up that deep domain expertise. The second point that I found is that personally, for our own hiring decisions and working with folks, we found that young people, so straight out of college, who have a really good set of kind of baseline knowledge, are really great at being AI native in a really interesting way. So using the agents to do things that would be very creative. So we have someone on my team who was just out of school and then used AI agents to build this whole orchestration monitoring system to look at. It's fairly niche, but basically the speculative decoding acceptance rates of the models to see, is there anything going wrong? Is the traffic changing in any way? And that's a set of things that previously you would need weeks and weeks and months of work, and he was able to build it in an afternoon, both using that creativity of, hey, I can do things that I wasn't able to do before, but also that deep domain knowledge of these are the signals that I need to look for that maybe before I would have had to build whole dashboards, but now I can just code up in an afternoon.
Thank you so much.
Let's see. Other questions? All right, so I think, here we have one. See, I think there's a mic coming.
Thank you. It's a fantastic presentation. So I'm not in the AI space, but I'm an AI user. And if we are hiring engineers or planning to hire in the next raise, should we really be planning to hire new people? Should we be spending money on hiring agents?
That's a really great question. I think you definitely want to be hiring really strong, solid engineers. I think sometimes you can, sometimes it can be a bit hard to read through the mix of the hype cycles and the doomsday. They're going to take all our jobs. But really, where we are right now is that the AI agents are really great at augmenting a strong engineer. So we haven't replaced anyone on the team with the AI agents. What we've done is we've taken really strong engineers who would have been productive and made them just much more productive. And I think what it can do is it can take someone and just make them more productive. But you still want that really deep domain expertise to say, hey, what do we want to build? How do we want to build it? What are some of the pitfalls to avoid? And how can I use my own domain expertise to work with the agents to work better? So I'd say the hiring story looks similar to how it always did. Find great people and sell them on your vision. And now hopefully they can just be more productive. And in my experience, my team has a lot more fun when they can work with the agents. Yeah.
Thinking on the future, let's say that what would be the best trade-off in terms of getting a talented, proactive team or more AI-related team? Let's say the scenario A, you got, let's say, a small team full of senior developers that are kind of more reluctant to get all the AI technology on their daily work. Scenario B, you got a half team where most of them are kind of junior mid-sized profiles, but they are all AI related, plus a couple of seniors, engineers validating all their work. what would be the best scenario in terms of I mean, is adopting this new AI technology and to embrace them?
Yeah, that's a great question. I think it will be different for different companies depending on what you're trying to build. We take personally at Together we take a mix of the very young talent, kind of fresh out of school talent that's very excited about AI and really excited to learn. But we also see the value in the folks who are a lot more seasoned and experienced. So we take a conscious effort to kind of recruit from across the spectrum. But generally, I'd say when I'm recruiting, when I'm hiring folks, I'm just really looking for people who are really passionate, really hardworking, and really excited about the future. And those things tend to correlate well with adopting AI and getting the most out of it and having fun while also being very productive. Yeah, I think there's one here.
Thank you so much for the talk. I really enjoyed every bit of it. And I'm Rishad from Graphene. We work on coding agents on local. And I'm particularly interested in what you think about the reinforcement learning loops and how it can make the open models work better in the tools that you were just mentioning.
Great question. So, we are very bullish on open models, I think. There's a lot to being able to kind of understand and reason about what the model is actually doing and reason about kind of where it comes from. And a lot of that we've seen, I think, a number of our customers are fine-tuning or running reinforcement learning on really strong open models and then building really strong user-facing applications on the other side. So we've seen it work a lot, and we're very excited, very interested in it. I think the key advantages are if you can really adapt the models for the use cases that your customers are seeing, that's very powerful. If you're working on building a local interface, of course, you can take the smaller models and get them to work really well and have them orchestrate with the bigger models. So that is something that we're very excited about, and I think I'd say very bullish on that. Yeah.
Do you have any particular experiment that you're gonna work on, just for the training? Because it's a quite broad market around here.
Right. So I don't personally have a lot of reinforcement learning experience. I know there are people at Together who do. So we've started looking at things like, can we train our own internal code generation agents and things like that. So I don't have all the reinforcement learning background, so I'd say I'd be a user of the reinforcement learning algorithms. But yeah, I think we're very excited for that.
Thank you.
All right, any more questions? Otherwise, I think we have some food sitting out. So I see there's a little bit of a line already forming. So I won't keep you from it. Thanks everyone for coming and listening. Thanks for the great questions.